You guys feel ready? Yeah! There we go, wow. Lane, I mean, yeah, probably true. So, as they say on the internet, GM. Happy to see everyone again. I hope your hangover isn't too bad. It's actually kind of nice that the room is emptied out a little bit, because I think that means that people had a good time last night. Let's move that cursor out of the way. Okay, we've got so much fun stuff to get through. It's kind of the wrong way to put it. This is going to be good. Fun stuff you're going to have to suffer through with me. Okay, so I'm going to try and paint the big picture. Why are we here existentially? Not really, in terms of why is this important for Urbit. Josh is going to talk about more specifically software distribution, developing on Urbit. We're going to dig into that mostly. So I'm going to start with kind of like the whole, how does this all fit together? And then I'm going to come back and talk to you about why software distribution matters and where it's going. So assembly as an event definitely marks an important milestone for this project, which I saw coming, probably 6-9 months ago, which I think was kind of a simple thing that happened, which is that I realized I didn't know everybody who was using Urbit anymore. That's probably true actually like a couple of years ago, but what I started seeing is that people were starting projects and even companies, and I had never met them, and I didn't know anything about them. And so Urbit for a long time was definitely just a small community. So sort of like what I was talking about last night, and the vibe was kind of like a bunch of people sitting around in beanbag chairs just thinking about what it could look like to use computers that didn't suck. And that community somehow recently has transformed into a young ecosystem, which I'm very excited about. And I want to talk about basically how we got there, why we're there, because I think this has been sort of designed from the start, and then where that's going and how I think that'll evolve. To reiterate, there are two parts to this. Okay, so we're going to start all the way back at the top. So I'm not going to tell the story of, in some historical sense. I want to talk about kind of like Urbit, how it's designed, and why it's designed to be an ecosystem just in its DNA. So in case you don't know why you showed up here, when I wrote this the other day, I was thinking, everyone knows this. And Tlon employees will recognize some of these slides, because we do this at every all hands, because I do think it's actually worth revisiting what the hell we're doing. Because it's weird. It's sort of easy to forget. I try not to forget, but I feel like it's my job not to forget. So in case you're wondering, Urbit is a peer-to-peer network and operating system that's designed to give people their computing back. That means that this thing belongs to you completely. It's open-ended. You can do whatever you want with it. I think of this as sort of like picking up the thread of what computing is supposed to be. But it's very much a technical project, right? We're trying to solve this problem that most of your computing is controlled by other people. So without digging into this technically, because let's be honest, most of you already know what the technology is, let's just stick to the high level. So one way to think about this, which I find is actually reasonably successful and makes sense to most people, is that we've seen this before, right? Well, maybe this isn't obvious to you, but in 1968, I wasn't alive then, a computer was this giant industrial appliance. Everybody shared access to it. You had to go to the computer center and like book time to use it. But not too long after that, a computer all of a sudden fit on your desk, right? It was this little toy that you could do whatever you want with. And so here we are again, we're in 2021, and all of the services that we depend on, they're these giant industrial machines. Everyone connects to them. We don't have to book time on them. Maybe that's like the one innovation that we got. But it doesn't, it's kind of a horrible user experience. But probably most importantly, and the most important difference, I think, between the mainframe and the PC is that ultimately the PC is basically more fun. You can use it in these kind of whimsical, open-ended ways, explore what's possible with it, which is a mainframe could never really let you do. So if cloud services are the industrial machines of today, then Urbit is sort of the PC by contrast. So I like to think about things in terms of the way they feel, And one way to understand this difference is that this is a PDP-10, and this is an Apple II, and you can feel the difference. This thing is fun. I mean, yeah, anyway, it's all kind of right there. So yeah, PDP-10 is a piece of industrial technology, right? And an Apple II is a personal tool. There is a place for industrial technology. I do think people kind of trip on this. Like, we used to say like, Urbit is little data. It's not for big data. And there's lots of good reasons that you might want to use industrial technology to do large-scale machine learning, whatever. Like, great. There are tools for that are very well developed. But what I would argue there are not great tools for when it comes to computing in the cloud is just everyday individual computing, right? We don't have great individual tools that really serve the people that depend on them. And so that, of course, is what Urbit is. The real problem here, I think, and the way that I look at sort of the contrast between what we've got in terms of this, cloud services are kind of amazing. Consumer SaaS does do incredible stuff. It's incredibly convenient. But all the things that we use, they're sort of pretending to be tools. Like, they have something very productive baked into them, and take your pick. So I refer to these really generically because I think of them, they're actually all kind of the same. So whether it's Twitter or whether it's, Notion, like, there's something broken about these things because they're controlled by one person. And it doesn't feel good to know that there's somebody in charge, even for things that we pay for. So there's something deeply corrupt, I think, about that relationship when something is supposed to be a tool that's mine, and actually somebody else gets to decide how it works. So my feeling about this whole thing is basically looks like this. So the way I look at it, great tools, like deeply considered, well-designed tools, are important because they let people do great things, explore new places, invent new things, and new ways of organizing themselves. We could have I could do another 2-hour talk about, like, the ethics of this, or why this is important from some sort of like deeply reasoned, I don't know, we don't need to get into like the philosophy of why this matters. Let's just take it at face value that this is important, or at least that I'm of the mind that this is important, and I would imagine that the reason that you're here is that you share some of these beliefs. So I'll go over sort of the 3 things that we try and keep in mind. So I'm trying to kind of like, if you set up, okay, what is Urbit? What is its ethos? Without getting into what it is technically, I think that's a good thing to do. That's the Urbit ethos calling. Because Urbit is a sort of technically ambitious and big project. So Tlon employees will also recognize this because we recite these things over and over. It's good to have design principles so that when you get into the weeds of what you're working on, you have something to come back to. So we like to think that Urbit should be simple, in the sense that you should be able to take it apart and put it back together yourself. You should be able to understand its component parts in the same way that you would like construct a geodesic dome. Urbit needs to be durable. It needs to be able to last an incredibly long time. You should be able to pass it down between generations. You should never worry about it failing or disappearing out from under you. This is a divider that I used throughout school as a drawing tool. It's from the 40s. We would always buy these Dietzgen drawing tools off of eBay because they were actually much higher quality than anything you could buy today. And I don't know, I always find these things amazing. Like, I didn't even, this wasn't like handed down to me in some generational sense, but I'll probably hand it to somebody else, and this could last for another 100 years, and it still works incredibly well. And Urbit should be yours. It should belong to you in the way that your sort of like personal space belongs to you, that it feels like it represents you. You can organize it in a way that makes sense to you. So we try and build this thing with these 3 principles in mind, right? Urbit needs to be simple, it needs to last a long time, and it needs to belong to you completely. So what's interesting, I think, and I think about tools in this kind of long-term historical sense. So things that are simple, durable, and belong to the people that use them, you can use these things to, let's think about like construction tooling, woodworking tooling, tools for going outside, getting into nature in like unexpected ways. The interesting thing about like a hammer or an ice axe or whatever is these things don't belong to anybody, right? They kind of belong to everybody. The design for them is totally distributed, and the infrastructure for creating them is also distributed. It's not there's no such thing as centralization when it comes to what great tools are. So you can think of Urbit kind of like in its just basic design and architecture, like as a system. It's designed to be like a city, right? You want this thing to belong to all of the people who depend on it, and that set of people could include institutions. It's like very distributed, such that, you know, like I was saying before, it belongs to nobody and everybody kind of at the same time. I feel like this is the kind of thing that sounds really good, and then if you take a step back, you realize it's a very difficult design problem. How do you build an ecosystem? So while you may be able to design how an ecosystem should work, actually executing that and building one is a very difficult thing to do. And so when I think of, you know, without doing this as a talk about all of the, I could tell you a bunch of funny stories from the office, right? But you can think about it like, okay, in 2013, this thing was a prototype, and in that prototype, you could see, okay, somehow this has to grow into a platform. Well, how do you actually do that? First problem is, let's just make it work. Let's get to like a baseline of functionality. You can kind of see that maybe this thing can go somewhere. And by the time we hit that baseline of functionality, we're like, okay, well, we want to get other people to use this and to take ownership of it and to build on top of it and to let it go somewhere. But how do you actually get that to happen? So we actually have this kind of dumb answer to that, which is just like, let's just build something for ourselves. Let's see if we can make this work for ourselves. And in doing so, maybe we can figure out how to distribute this more broadly, how to make this into something that can belong to other people. So most of you are familiar with our answer to this, which is landscape, which I imagine a good percentage of the people in this room are familiar with and probably use quite a lot. So building Urbit, a lot of it did actually, for a long time, happen in one room. But of course, people move around, and we work with people who are all over the place. And if you care a lot about the quality of your tooling and how it's going to evolve, it also matters a lot how you're going to communicate. So building landscape was, I think of it kind of like building a lathe. So a lathe is, this is not completely true, but people like to say that a lathe is a machine that can build itself. So if you're going to, this guy gets it. So if you're going to, you know, move a community forward that is also going to build the tools that it needs, you need to build something that community can use to build those tools. Landscape was kind of our answer to this. We want to build open-ended systems. We care about computing generally, so we wanted to build something that's relatively flexible, but that can also support our day-to-day communications, our community, and for the most part, it's pretty successful. I think, honestly, one of the things I like the most about using Landscape every day is that it doesn't beg me to turn notifications on, and also that it's not like purple or plaid, or like it just doesn't look like something that is obviously selling me out to somebody else. The most important thing about Landscape, though, which I think most of us, yeah, we're all familiar, we know where we are, right? This thing works, it's pretty nice to use. Okay, cool, why does that matter? The reason that it matters is because Landscape, in building it, both our like work as Tlon and in working on it with the community, we sort of cut a path through the woods, right? I remember these conversations in like 2016, 2017, we're like, okay, this thing kind of works, like, how do we ask people to participate? And it felt like you're down in the valley somewhere, you're like, okay, we need to get up there. We have no idea how to get there, and we certainly can't tell anybody else, hey, you should go up there, like, go figure out how to get up there. You know, you got to cut a path through the forest to actually ask anybody else to follow you. And so building Landscape is not just an act of figuring out how do you develop on top of Urbit, and that's what we're going to spend most of today talking about. It's also figuring out a path for other people to participate in basically moving Urbit forward writ large. And so the thing that I want to cover is the different groups of people who I think can participate in doing that, who most of whom are actually here. A lot of you are developers, but there are other groups involved as well. So what I learned from working on Landscape is really that it showed us a prototype of an ecosystem, that you can have communities, operators, and developers sort of naturally work together to move this thing forward. And so I'm going to walk through quickly how I see these things, because it's become obvious to me that these three groups kind of have a natural form of collaboration that is also kind of different from how crypto networks usually work. So crypto networks in general have this kind of single incentive, which is like, I don't know, if everybody believes in this thing, then number go up, and then more people believe in this thing and number go up some more. Urbit does have some of that. It's a little bit different though, which I like to think of it as like, as Urbit becomes more useful, it becomes more valuable because people want to pay for it because it is useful, which makes it easier to fund its own development. So there's one feedback loop. But in order to satisfy that, in order to actually make Urbit useful, you need a few different communities, or this is one I always trip on. You need a few different groups, because one of those groups is communities, to work together. Anyway, let's walk through this. This is definitely how I see it. I think this, we could do assembly next year, and I could be like, okay, the ecosystem is slightly different. But in any event, I think I think of this as kind of like the prototype of the ecosystem that has emerged over the last year or so. And I mean, we could be with this forever. I think this is very much kind of part of Urbit's design. Anyway, the first one is somewhat obvious. So communities depend on Urbit from day to day. They already do now. There are always going to be communities depending on Urbit from day to day. Most platforms would call them users. I think of users, users always sounds like drug users to me. It's like such a condescending way to talk about the people who use what you make. In any event, the reason that I like to talk about communities is because Urbit's a networked computer. So you're almost always using it with other people. And the reason I'm saying this in very generic terms is because while communities today are obviously, starting groups on Landscape and so on, this is much broader. This is just people who use Urbit because they think it's nice to use. And in order for communities to even exist on this network, they have to be supported by developers. So I'm also going to quickly rattle off what I think, like what I see is happening next for each of these things. And so with communities, we've got Landscape, but there's something missing, like they aren't totally thriving yet. So the nice thing is that I think the next step is getting to the point where you can basically get onboarding communities just like, I send you an email link, you sign up, and you get on the network. And this is a shared, this is an effort that's going on both between us and the community at large to basically get, fix the gas price problem by moving to our own L2. We're working on hosting, other people are working on hosting, and then we're working on an iOS app so that I can send you that link, get you signed up, and get you sort of like actually connected to Urbit in a long-term form in a way that's totally familiar, where, like I said, you're just using Urbit because you think Urbit is nice to use, and you don't think too much about what it is. Okay, so what is an operator? It's kind of a weird word. It's definitely a weird world. Operator is a weird word. What I mean by operator is basically anyone who owns a significant chunk of address space, anyone who owns a star or more. So of course this thing is meant to be owned by anyone who wants to buy a stake in it. You can go in OpenSea and you can buy a stake in this thing. Some of the people who do that are doing that purely because they want to participate in the economy of Urbit, right? Does this address space have value or not? And participating in answering that question is certainly a thing. We love it if you ran a node, and many of these people do run nodes and basically keep the network online. So we need these people to exist in order to keep this thing running, in order to make it useful for people. These people wouldn't be doing this, of course, if communities didn't care. And the most productive way for them to put their address space to work is to actually go and fund developers, right? This address space has value if it's useful, and developers make it useful. A lot is going to change for these people because address space is going to become fractional soon. So this has been a problem for us. Yeah, probably. It's all on this kind of same time scale. I think about a year or so ago, it started to become problematic for us to be able to actually figure out how do we grant people in the unit of a star as stars are becoming more valuable. So it's like we'd love for people to work on projects, but I have to think of projects now that are tens of thousands of dollars for people to work on. So now you'll have the ability to commit a star to a contract that was developed by the community and commit an ERC 721 NFT and get a fractional token back, or like a fungible token back that can be fractionally divided. And I think this will really accelerate operators' ability to distribute ownership and basically fund projects and move the network forward. So I'll end with developers because Josh is going to talk a lot about developers in a minute. Developers are obviously super important to Urbit because these are the people who explore what's possible with the system, much of which we may not even know, and it certainly is not yet known, right? There's lots to explore and to figure out. And these people figure out what's possible, and they improve the day-to-day user experience by finding things that are useful to people. I think the primary way in which these people will be supported is by existing address space holders, as I've said a couple times. And we'll use address space to fund those projects, and we have so far done this pretty successfully. I mean, I think Tlon is an obvious success story here, at least so far. But you see other projects and businesses starting to get off the ground just by the existence of their address space holding or through the foundation and through grants. So the most important thing for developers these days, of course, is software distribution. Now you can package something up and just send it to your friend over the network, and they can run an application. I'm going to let Josh show you how cool this is, but it's it's pretty insane. I actually, probably more so than any, it's hard to, it's never a good look, I think, to tell someone that something is magical. They have to experience the magic that it is. So we're going to show it off to you, but I honestly think that the ease with which you can package up and ship out an application over Urbit is it's really quite unbelievable. And what's possible with this, I don't think we understand yet, but it's very, very cool. So part of supporting this is, of course, moving the Urbit Foundation out into a separate entity and accelerating its work and letting the foundation actually go ahead and fund a lot of people to build projects and see what's possible here. So the nice thing about this model, which I think very much already exists, there are individual developers, there are operators, and there are community members who are here, and I know that these people are already supporting each other, independent of us. And while we participate in this, basically, we as Tlon participate both as all three of these things, I see other people doing it as well. And the end goal of this is not just for an ecosystem to exist, right? The whole point of this thing is to provide a toolkit for people to build new forms of communities, tribes, subcultures, cults, communes, whatever. The thing that I think get the most excited about when I think about the potential of new forms of software is what communities are able to do when they control their own tooling and they sort of move themselves forward. So again, I'll try and give you some just visual examples because I do think that think of what it feels like. So some of the people who are the most influential to me, or that sort of started to gel this idea, are definitely the early Yosemite climbers, which if you're not familiar with this story, is such an incredible story. Climbing, as some of you maybe are familiar with it, this was not a thing. People did not, climbing vertical walls was not possible without basically inventing a whole new toolkit for doing so. And definitely climbing vertical walls where you're on the wall for multiple days at a time requires people to, invent their ability to do so. It's an incredible story. And the culture that emerges out of out of this small group of people, and it's a tiny group of people, is amazing and really is honestly inspiring. Another one is the Bauhaus. This is Annie Albers and her class. So much of visual culture that we live in is influenced by this tiny group of people, who in some ways are very much at the fringe of what people were thinking about. And we're inventing, new ways of making things, new ways of making visual work. And then I'll end on something that I'm hoping at least a few of you are familiar with. This is the MIT Wearable Computing Group, who I was not familiar with as a kid, but definitely this form of hacker culture I was very familiar with. So 90s hacker culture, 2600, Loft, Frack, that whole world. These people really had a very direct relationship to their computers and were able to explore what they could do in a way that I think we really don't do anymore. So look, this is not, as my friend Eric will say, to put a bottom line on it, this is not abstract. The point of laying this out is because you are all literally here. So sure, we set this up mostly as a sort of developer-themed event, and there's a lot of time to work together and to start exploring what's possible with the system now. But in the room, there are operators, and you should be funding developers. Find developers here who want to work on projects and give them address space to support their work. Doing so moves this whole thing forward. Obviously, there are tons of developers here who want to experiment with the system. That's great. I know there are also community members here who are just love hanging out on Urbit. Talk to them and figure out what they need, because you can build something, your audience is here, you can learn from them. And I know there are communities here who just think it's fun to use this thing. So keep setting down roots. Figure out what it is that you need from Urbit and talk to developers about it. And tell operators what you're doing. Tell people like what's going on. That's basically it. Thanks. I'm going to hand it over to Josh. He's going to dig in a lot further on software development or software distribution and where we're going there. I think it's even in here, isn't it? Hey.
Hi, everybody. So for about the last, year and a half or so, I've been talking to tons of you on calls, on the network, and one of my favorite things to do is get origin stories. How did you end up at this project? They're always really entertaining, and what I found is that there's a ton of commonalities. Lots of people I talk to, they get into this 6 years ago, they keep coming back to it, and eventually it just like pulls them in, right? People always get sucked into this gravity well that is Urbit. I was the same way. And I'm going to tell just a little bit of my origin story as a way of segueing into what excites me about what we have to show you today with software distribution. So for me, back in about 2012, I was just starting out my career in programming, and I was always checking this thing, Hacker News. You probably all recognize this. As far as I could tell back then, Hacker News was cool. Either that or I was uncool, but it seemed like there was always cool stuff popping up on this thing. It wasn't just a bunch of lame SaaS stuff like it is today. And I remember at one point I was browsing around on there, and this thing came up. I was about 2 years into my programming career at this point. I was at the point where I never actually read the comments on Hacker News. I don't know why, I just didn't. But this seemed interesting, so I clicked on it. It had a lot of upvotes, and I was totally lost. I had no idea what was going on here. I was really just way too junior to understand what this project was. But what I do remember is that someone had gone through a lot of effort to invent a lot of words, and it seemed really cool, whatever it was. So I made this kind of mental footnote that I should probably check this out again at some point. Now, at the time, I was busy. I was working on my first startup. It was like a SaaS company, but without the recurring revenue. And I was, first I learned Node.js, because everybody was learning Node.js at the time. It was really hot. Then I learned Clojure, which I'm going to talk more about a bit, because this one actually stuck. I really liked Clojure. Then I built a database in MongoDB and then quickly ran away screaming. But unfortunately, I went to Elasticsearch, and after about like the 5th or 6th time of implementing joins and application code, I remembered Postgres and SQL and what that whole thing was for. And so I then wrote my database in that. Well, then I learned about Datomic, and I wrote my database in that. And then I needed a front end, so I learned jQuery because people were still doing jQuery at the time. And then I rewrote it in Angular. And then React came out, and I rewrote it in that. You can sense a theme. Eventually, I had to learn Linux system administration, and there's a whole bunch of things under there that I just stopped doing because you get the point. But it was immense. Like, there was a huge amount of stuff to learn, and I thought it was really cool. I was having a great time. But what I built was this giant mess of complexity and kept rebuilding shit over and over and over again and never going anywhere, and, recurring revenue didn't happen. So at about the time, I also got into this. I found this talk. Has anyone seen this? Simple Made Easy? You may not have seen this. You've probably seen other talks that are like it, because this is something I've seen a lot of in recent years. This is a talk about complexity in software systems. And I'm going to paraphrase this a little bit. I can't quite do it justice. I'd recommend you watch it, because I've watched it probably 5 or 6 times over the last decade since it came out. It's very good. The central theme behind it is that there are these words, simple and easy, and we often use them in the same breath, right, to describe what we think is the same thing. It's like, oh yeah, that's easy and simple. They actually mean totally different things. And it's really useful to have a framework for thinking about why they are in fact different. Because the software you build, if you're optimizing for one or the other, you end up with actually totally different systems. Hint, most people optimize for easy. So let's talk about that first. Okay. Rich says, well, modern developers are obsessed with this, and this was in 2011. I think this is still true. Like, we like to be able to npm install something, and then 5 seconds later, we're up and running. It's good to go. It doesn't matter if it is an absolute ball of mud. Right? We just like to go fast. Right? Who doesn't want to go fast? Now, the problem with easy is that it often leads to complexity that we'll talk about in a bit. Right? If we over-optimize for ease, we end up shooting ourselves in the foot later on. Right? Now, the thing about easy is that it's actually relative. In his talk, Rich says this, like, I can't read German. Does that mean German is unreadable? No. He just doesn't know it. Right? Easy is a relative term. What's easy to me may not be easy to you, and vice versa. And so we don't want to think about our software based on what is easy to us, yet often a lot of the decisions that we make are based on what's familiar. Okay? Simple. It's totally different. This means something that's composed of a single element, right, or a single concept, or that has a single role. And it stems from the word simplex, or one twist. And the example he uses is like a strand of rope, right? And it's only got one strand. It's not intertwined, okay? And as programmers, what this means is one concept, okay, not just one thing, right? Complex, consisting of many different and connected parts. Like connected, I underlined that because that's really important. But if you have lots of different things that are all intertwined, you can't pick out one of them and think about it independently. You got to take the entire group of things. And this is a big problem because humans have like just basic fundamental limits on the amount of things that we can hold in our head at a time, right? The least mentally gifted of us can handle like 2 or 3 things, and the most can handle 5 or 6, right? We don't have very wide variance on this, and this is just a bummer. But it's a fact, and with software, we can build things that involve way more concepts than 5 or 6 at a time, right? And we build something that's very complex. We cannot reason about it independently without having to take everything into consideration, and that's bad, okay? So if you optimize for ease, and you optimize for picking up things very quickly, it's like, oh yeah, let's grab that, let's grab that, let's grab that, because I could just npm install all of it. Eventually you end up with this, right? You're a technology hoarder. And before you know it, your system is full of useless bullshit. And you know, good luck wading through that. You know, let's try and refactor it 5 years later. Not going to happen. Right? In Urbit, we call this the big ball of mud. Right? And the problem is our entire software stack is this. It's a big ball of mud because we've been optimizing for easy things for years and years and years and years and years. And so now when we want to reason about building anything, right, we have this giant tar pit to deal with. Now, last weekend, I was writing this talk. I don't usually write talks a week in advance. You're all special. I got on Hacker News again because sometimes I still idly do this. It's a hard ingrained habit. I got on Hacker News, and almost as if it had been put there for me, there was this headline last weekend. I built a modern website in 2021. It's like, okay. I bet I know what this is going to look like. I bet it's going to be a little overcomplicated, but I'll give it the benefit of the doubt. So I clicked through. You know, like my wildest expectations were totally exceeded. Right? That's the deployment pipeline that has Discord in it for some reason. We have, you know, an authentication flow and a session flow and database connectivity, which is sharded globally. We have something called fly request replays. I don't know what that is. I don't want to know what that is. This is all the technology he npm installed, and those are all of the, you know, the third-party services. Now, he probably thinks this is great, right? This is, you know, like probably what I was like back in 2012. I think he probably looks like this, right? This is insane. And it's not just me. Even Hacker News thinks this, right? This reads like the onion piece for developers. It looks like a pure nightmare, right? There's so much complexity that doesn't need to be there. I honestly cannot tell if this is satire or not. I'm so glad I got into web dev in the 90s when all you needed was a simple text editor and FTP client. Right? This is just absurd. So, going back in time a little bit, it was about 2016 that I came back to Urbit yet again. And this guy, and Curtis, explained to me over 10 minutes what Urbit was. And I was like, oh, I get it. Like, this makes perfect sense. Right? Urbit is a simple system. It's different pieces all talking together. This is a great drawing that, well, you've seen this art all over the place, but that's meant to be the veins of Arvo all communicating and arguing amongst themselves. But you can see how they're little building blocks, right? Urbit is simple made easy, but on a way more fundamental level than a programming language, right? It's, let's take the entire software stack and simplify it and give ourselves much better primitives to work with. So in Rich's talk, he's got this slide called What's in Your Toolkit? You know, and he's making the case for Clojure in 2011, which has all of these, you know, simplicity-oriented concepts. And he's comparing it to the complexity found in traditional object-oriented imperative languages. I'm going to do that with up a couple levels, right? Because these are the things that we have to work with when we choose to develop on Urbit. Okay. What's simple? And I don't mean easy, because actually building one of these things is hard. Peer-to-peer is simple. It makes sense. Like every time I use any application that involves talking to somebody else, what I think I'm doing is peer-to-peer. Like I'm sending my mom a text, but I'm not sending my mom a text. I'm sending my text to some other place, and then I'm hoping that they relay it onto my mom. Right? Many such cases. Right? Peer-to-peer maps onto our mental model of what we think we're doing when we communicate with other people. It's what I'm doing right now. Right? I'm just talking to you. Client-server is actually very complicated. Right? It involves introducing this middleman into the middle that we then have to optimize and pour thousands of engineering hours into making sure can scale for dealing with the world's information. Right? So we can move on to the next one, global scale. I mean, what could be more complicated than trying to deal with the nuance of the entire world all in one place? I would much rather have community scale. Like, let's let the world organize its data and not try and organize the world's data. That seems much more sane. Authentication systems. These are not simple. Anyone ever built an OAuth 2 system? Yeah, the rest of you are lucky. Like, it really sucks. Who likes logging in? Yeah, yet it's what we do all day long. We log into a bajillion things, and it sucks. Right? What's simple? Identity. We've all had one for as long as we can remember. Right? That's how humans work. We have identities. Only one. Right? I mean, maybe a couple. But, you know, but we relate to the idea of identity, and with identity we build reputation. This is another thing that we can map onto. I don't need Yelp to moderate the reviews on my business. Right? I have a reputation based on the people that know me. Right? Moderation sucks. I have a friend at Facebook who I talked to about a year ago, and he was telling me how much they hate having to do all of the moderation. They have, you know, multiple tens of thousands of people that are devoted to moderating content on there because they are forced to, right? They have to, right? If you've ever built an iOS application, submitted it to the App Store, it has some component of social, and they got it rejected because they say, no, you have to censor people. You need to install flagging and have a moderation system. No one wants to do this, but we have to because of client-server. Right? There's always this middleman that is necessary. Okay, I'm not going to talk too much about this one because it kind of goes without saying. What's complex? Non-determinism. It's like, turn it off and turn it back on again. How many times did you do that? Determinism. If I do the same things over and over again, I get the same result. That's pretty simple. Databases? Anyone ever deployed a database? Or 4 or 5? Or, you know, different databases? Like having all of your data stored in some extra system, right, that you have to maintain. I'd much rather have a single level store. I build my application, all the data that I work with is just there and persistent. Right? I don't even think about a database because my computer is a database. SaaS, it's not simple. It complex business and an application. Right? Not everything needs to be a business. Right? Anyone have a thing that they have to sign up for that shouldn't really be a service at all? It's just like a fun little thing. Right? You shouldn't have to actually build a business to build a thing. And the tragedy is that so many things that should actually just be simple and fun to build end up having to be businesses because it's so damn complicated to build them in the first place. That you have to sink all this money and resources into building something, so it has to be a service. Tools are simple. Right? Galen covered this. Right? Something that just does a thing and it works and it keeps working. Kubernetes. Yeah, no, that's complicated. What I would much rather have is some code that I put in a place and I run commit and I'm done because now it's running. Right? And that's the Urbit deployment model, is you stick your code in a place and then it runs. Cool. So yeah, let's we'll dig into that in a minute. Now, all in all, like I think what a lot of us want to get away from is this. Right? Like industrial computing. It's really complicated, often soul-crushing, not very exciting. Too many of us are stuck doing this. Like we work on these kinds of systems. Okay, we want to work on things like this, that are ours, that are beautiful, that we can understand, that we decorated ourselves. Right? This is what I want to work on. So Urbit, right? It provides abstractions for building human scale applications, right? Really the kinds of things that we want to build that don't make us have to consider all of this extra complexity just in order to build our idea. But Urbit is just an over-engineered chat app. We hear this all the time. And it's really annoying. No, we have links and notebooks. But, you know, like, they have a point, actually. Because, you know, it's been basically impossible to ship a piece of software to Urbit that didn't come from Tlon. You know, so for all of these lofty ideals we have about enabling developers to build simple tools, there actually hasn't been a way for you to build a simple tool, and that's kind of a bummer. You know, this hit a year and a half ago, more, and it's still basically got the same feature set. You know, all of these things have improved a lot, like an absolute ton, not to mention just the way in which they work, which Ted will talk about a little bit later. And it looks like it's something that you should be able to extend. And we actually had this for a long time where we said, okay, well, we got this nice tile-based interface, looks like an app launcher. We want you to go and build applications. So here's this template, you know, so you can go and create a landscape application. And in that entire year and a half, I'm guessing the only other application that anyone has ever seen come into your Urbit is this one, the Bitcoin wallet. How did that get there? Why is this one so special? Well, because it was a pull request into the actual Urbit repository that was reviewed at Tlon and then approved after a lengthy review process. Which is not to downplay the achievement of this, because this is a really great, this was a great thing. But the idea that you need to have Tlon or any organization moderate your application in order to get it released to everyone on Urbit is an obvious anti-pattern that we've all known about for a very long time. Right? Now, this wasn't the only way you could do it. Like, you could also, you know, you could actually ship software to people, but you got to be a little careful. You know, if you want your mom to use the application that you wrote, you're going to have to teach her how to use the dojo and set up a sync to a remote desk. And if you want that application to keep working, you're going to need to tell your mom to use a moon, because eventually an OTA is going to hit and it's going to break and then nothing's going to work anymore. And your application had this, you know, annoying habit, like it could just rewrite the entire operating system if it wanted. That's bad. They had no sandboxing. So we needed to build some infrastructure. So this took a few months, actually, and we actually built it. It didn't cost very much. There's basically two big things that were worked on. One, it needed to be possible to sandbox your code, right? It shouldn't be the case that user space code and the operating system live in the same place and can be overwritten. Like I can ship an application that rewrites jail with key stealing jail. Bad, right? Or have 7 applications that are all doing that. That's also bad. And it also needs to be the case that if you get, you have one application and you have your system and then the system changes, it's got a, there's a breaking API change. It needs to not be the case that now your ship's just broken and you have no idea why and why you're locked in this, previous version of history in which everything worked. Okay, so there needs to be a way to negotiate actual changes to your software. Right, so that had to be done, but then what about the user interface? Like, how do we actually represent this and get something to you? Well, we ended up with this, right? This shipped a couple weeks ago. This is the new landscape. It has been reborn. But now is a proper operating system, right? It has one major killer feature that is different than it did before. And it's not just that it looks really clean. We still have Leap at the top, which is, can't quite see, but there's a search. You still got notifications, hence the big blue thing with the 1 in it. You still got system settings. And you still got tiles. Right? It's that these things each correspond to self-contained desks of backend code that you can run on your own personal server, right? That are actually isolated from the rest of the operating system. And should an API ever break, you will have the ability to decide, do I want to keep this thing in its current state, or do I want to take the operating system update? In other words, you can't get your ship into some broken state, right? Updates will not break your computer. That's good. What goes into this desk, and what does this tile launch? Well, if you've been playing with this and following along, each one of these tiles opens up a new browser tab. Right? This is a fairly simple thing for us to do. We expect that a lot of these are going to be web applications. They don't all need to be web applications. Right? You could build an interface on any other front-end or client-side framework, call it an iOS application. I open the app, it takes me to the App Store, says download this thing. But all of the back-end software that you need to run that application is now running on your computer. Right? An important thing. So what do we want to see? Like, what is this good for now? Right? You cannot build every application imaginable under the sun for reasons that Ted's going to talk about a little later. But there are a lot of things you can make. Right? Modes of communication is one that I'm really interested in. Right? We have links and notebooks and chats, but there's actually a lot of other ways for people to communicate peer-to-peer. Right? Ed's going to be working with a group on building a writer a little bit later. Right? That's a good one. Galen's particularly fond of the idea of a Twitter clone that only accepts haikus. He would be. This is Galen. There's a lot of things you could do. Like, you could do really any kind of application that involves people talking to each other. A forum would be great. Like, forums are a tried and true thing that actually work pretty well. Okay? Now, this is a cool one too. Like, we actually, I'm calling out Gnosis Safe here because it's one of the dApps that I use. dApps have a problem generally, which is that often they need to store data that isn't on chain, like metadata and other mappings, say, from your address to something else that makes it make sense. And so what do? Well, Gnosis Safe just puts it in local storage in your browser. Like, that's a bummer if you manage a lot of vaults for this specific application, because then you got to go and find them. Like, they're public data on the chain, but you got to remember what vaults you want to add. Right? It would be really great if you could actually store the server side, but you didn't have to do some shitty login service and then trust this party with the knowledge of what your information is. And many dApps have this problem of, I have chain state, and then I have all the other state. Where can I put the state? And then not sacrifice like dox the people that are using this thing, which is kind of important. Okay, so there's a whole class of applications you could build there. I'm not an expert. Lots of you probably are. So we're happy to talk about that. But there's also a whole other range of applications you could build, right? You could just build fun things, like auto laser. You enter a bull run, and it just goes to your Twitter profile and makes sure you have laser eyes on, just in case you forgot, right? We're not actually used to having personal servers that can just act on our behalf. Not everything needs to have an interface, right? We can have code that just does things for us that runs on our own server, okay? There's a bunch of things like, even just today I heard that chess shipped to the network. I gotta go find it. I didn't have time. I had to come here. But this is becoming a more and more frequent thing that just about every day I hear about some new application that's being shipped, and that's been 2 weeks. There's poker floating around out there. I'll leave you to make the connection with the Bitcoin wallet. Okay, so let me wrap this up a bit with another little anecdote. About a year and 3 months ago, I talked to Phil. This is when I was planning on coming to work here. And we had a conversation. I can't remember exactly what we talked about, but thankfully I have this email because it told me what I talked about. Phil says, "This is what I mentioned in our call. I'd love this to be our future." And this was actually older than our call a year and 3 months ago. This was, from what I hear, this is about 2.5 years old. And in this are 2 fake Hacker News posts, right? Hypothetically from June 6th and July 14th. And in it, there's a story of this person who shows up and has built this side project. He learned some tech and he built a thing. He had this flash of inspiration in the shower. It's like, oh, I have an idea for a thing that I need and that solves a real problem. I'm going to go out and build it. And he built a prototype. Right? And it fills a real need. But he's not rich yet. He can't get people to use it. Right? He's not sure why he can't actually get this to a point where people could use it. And some very helpful person on Hacker News comes in and says, well, here's what you're going to need to do if you want to actually get this thing out into the wild and make it successful. You're going to have to make sure that users can sign up. You're going to have to build an app so that they can get it on all their devices. You're going to have to spin up some servers and a database so that you can store your state. And then you're going to have to talk to a lawyer because you're going to be managing people's data. And because all this costs a lot of money, you're going to need to raise a round and do some fundraising and get an office. This really resonated with me because I've had countless side project ideas like that first one that I thought, wow, I should build this. And I sit down for a weekend. It's a weekend project. I build a lot of it. And it comes time to deploy it and actually consider what's going to be involved to make this thing real. I start working on OAuth. And then I give up, right? Because I don't have the bandwidth to actually get this into anybody's hands without having to invest this ridiculous amount of effort into making it real, right? Well, a month later, the same guy gets back on and he says, hey, Urbit totally changed my life. It turned this side project actually into a total sensation because in a month's time, I was able to take this thing, build a little prototype, and get it directly into the hands of users because I didn't have to deal with all that other bullshit. Now I'm iterating on it. I didn't have to quit my job, so my wife is happy. And it's great. Right, so even before that, Galen said, well, at the end of the day, we may not yet know what Urbit will be most useful for. The future of Urbit lives in the imaginations of developers that build on top. That hasn't been true, but now it is. So, let's build that future. Okay. Thank you. We're going to do a demo now. I'm going to welcome Ed and Jake. Just about everybody knows Jake and Ed. These are some pretty prolific people. Fabled faster, little wolf for everybody. Although I also forgot, because I didn't go to the slide, that we're going to take a break because you've all been sitting here for a long time. So in a minute, you should come back and watch these guys give a demo, which is going to be awesome. But take a break. We'll come back in a minute. Hello, hello, hello. We are going to get going again. If everyone would file back in and yell at all those other people out there to file back in, that would be very helpful. We're going to get started again in about 15 seconds. So get your seats. We get the video going again? Oh, you do? Okay, cool. If you know how to do it, then go ahead and do it.
They got it.
You got some notifications.
Nice.
Oh, look, we need to refresh this. Is it command like this? Command R.
Marissa?
Oh, the projector isn't on right now. Or video.
Okay, there we go. All right, welcome back, everybody. Oh, it went away again, damn it.
Oh, yeah, maybe the.
Is this the same?
This is the same one, yeah. Yeah, there we go. Oh, yeah. There we go.
Technical difficulties. Okay, so again, let me introduce Jake Miller, Little Wolfer, Edouard, everyone knows him, Fabled Faster. We're going to do a little demo here. Actually, I don't know what I'm doing. I'm going to give it to you guys.
All right. Hello, 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 hello. It's wonderful to see you all today. Happy to demonstrate some of our latest work to you all. And I'd like to welcome you to the performance art free jazz section of the presentation. So without further ado, I'm going to step out of the middle, and just we can begin to sort out what exactly is so special about this product we just shipped. So, oh yeah, it's all over there. So are we starting there?
No.
Okay.
Gotta show the main screen.
Yeah, let me just. All right. So I'm going to use a laser pointer here. We have no slides. This is a live interface. What we have here is Fabled Faster running on our hosting service. So this is just on the web, and we have another ship running locally on the machine, which we're actually going to demonstrate how one would go about publishing an application and just getting right into that. So there isn't too much to show here. What I can demonstrate very quickly, if you'll give me a moment, is the mechanism for going about searching for applications, developers, etc., is through this Leap cluster, this search input at the very top, at which you can see I've searched for a couple of devs. I could tab down, explore, and look for something, and ideally just download apps as easy as I could actually go and send a DM to someone. So that's the hope here. I think we can actually get into just to the app publishing flow. Let's check it out.
Look at Mr. Dister Little Wolf.
All right. This is hard to do with one hand, so give me. It's okay.
You gotta put the dash.
Oh, okay. Mr. Dister Little Wolfer. There we go. So what I just did there was search for a ship, any ship on the network. In this case, this is
the ship running.
Yes. So what we did right now is just search for a ship, an arbitrary ship, and we can see that in this list right now, there is no applications shown. This is a ship that has not yet published a public application. And what we're about to demo here is how one might go about publishing an application, and then we'll go ahead and see me try this again and see how I can just easily download an application from another ship. So You can get right into it. You ready?
Yeah. Can you hold this?
Yeah. You'll have to be looking back at the screen, so.
Yeah. Okay. So this app here is the Pals app. I'm sure a lot of you have already installed it, actually. This is by Mark Palfon-Foslap. And so what we're going to show here is that I've already installed this on the moon, Mr. Dister, little wolfer. And you can basically treat this as, oh, this is an app that I have developed, right? Not that I have. Mark did this, but every app that comes into your Urbit comes in as a desk, right? So which means that you can basically just treat any app on your Urbit as your app. So because it's sandboxed, you can essentially just publish this and send it to your friends and act as if you wrote this app, which is a good thing. You're not copying anyone, you're just redistributing apps. So say, for example, you've installed an app from Zod, and then we haven't fixed HDMI issues yet. So yeah, if we look here, you can see, man, this thing is very sensitive. Oh yeah. App info, oh no. Okay, here we go. So developer decks, pal dev, pals, right? So this is where we installed it from. Now I'm gonna go and feel like oh, God damn it. There we go. And now I am going to go over to the dojo. This is my Mr. Dister dojo. And I am going to publish this app. This is so difficult. Better? Jesus. Right, so now I've published Pals as Mr. Dister. So you can see here, it's now talking to people that are listening to Mr. Dister, right? And so if we go over here, back to Ed's ship. Look at that.
Magic.
And so now you can just install that. Get out. Yeah, sure.
All right. So, no, it's okay. I can hold this. We definitely should have ensured that we weren't having to look behind us as we were doing this, but you can all see that now that Pals is downloading, we can exit out of it, maybe prompt it with a little refresh, and we can see that Pals is now on my ship. Is now live. If I go ahead and check out the info, we're going to go ahead and see that developer desk is this, but I did just receive it from Jack here. Yes. So it's exciting. Apps work. They can be distributed. We just did this live. You can see here I have some Pals already. So there's some you could be sending me pings to this right now if you are all connected. But this is it. It's simple.
Wait, so we should show.
Yeah.
This is, the Pals that I installed on Mr. Dister is also still Pals, right? So I can still use it. So I wanted to show us adding some Pals. Yeah. Now let's see if I can drag this over here. Oh my God. There we go. Is this gonna work? Can I just? Oh, hey, look at that. So see, you can see here, Mark already added me, Palfon-Foslap, right? So this is actually all. This is all Hoon. All of this. There's no JavaScript here. Which is kind of the coolest part. And this is why I think it's cool to demo this app, because this whole thing was written in Sail, which is like a templating language in Hoon, where you can basically just statically serve sites. So yeah, all this did not require any node builds, NPM builds, anything like that. Yes, everyone should clap. And so I'm going to add my fiance. So let's see if she's on. I don't know. She might be at work. See, so you can see it updated here. This is like the sign for whether or not someone has added you or not. So this person has not added me yet. this person has, right? So I can go here. Oh, yeah. Now we're pals. Now let's see if I'm pals with my fiance yet. Yeah. Nope. Oh, hey, look at that. No. I guess she's not on. Oh, well.
It's okay.
There we go. See? It's nice. Now I can add my parents, too. Malix. So, look. Smiley face. My fiance is my pal.
Thank you, thank you, thank you.
So, yeah.
So that's it. You know, we could get into this much more. We could add more pals. We could install more apps. But this is it. It's simple, and it works. And that's it. We'll now be transitioning over to Ted's more technical exploration of the undergirding work that goes into software distribution. So I'll just go ahead and advance the slide, and everybody say hi to Ted.
Thank you. Good job. I have a much easier job because I don't have to use the mouse. That was the hard part of the demo, it turned out. So hi, my name is Ted Blackman. You might know me as Robinus Rickfer. I'm one of the kernel devs at Salon, and I'm going to be talking about the technical roadmap of Urbit. So I'll start with a look back through Urbit's history. You may know Urbit was started about 19 years ago, in sort of murky days of 2002. And it's come a long way since then. So Urbit started as just an idea, and that idea is knock. So you've probably heard of knock. It's Urbit's functional machine code, and it's a very tiny spec. This is the specification right here. You may see some people here wearing knock t-shirts, and it's a beautiful idea. Right? The concept is you can have a computer that's formally defined, it's deterministic, it's a pure function, it's very clean, it's axiomatic. You know, it's a beautiful idea. However, there are a lot of beautiful ideas in computer science, and most of them don't go anywhere. So what's interesting about Urbit is that it actually has gone somewhere. So, okay, we start with this spec, knock, and then we have to actually turn it into something that you can use. So I'm going to go through the history. There's several steps here, and I'll go from 2002 to the present day, and then I'll talk about what remains to be done on the system. So the first step, starting, I don't know, 2002, 2006, no one really remembers, but it was a while ago. And a bunch of things had to be done. So first, you have to have something that runs knock. Knock is a machine code, but there's no hardware for it. So you have to have a virtual machine that runs the knock. So you need a knock interpreter. All right? Then you need a programming language that you can use, because knock is designed for machines to run, not for people to write in. So that's Hoon, the programming language. You need a compiler for that language, Hoon compiler. You need an operating system, right? Like this thing has to actually do something. So you need some code, that's the Arvo kernel, that actually is a system, right? It's actually a piece of code written in Hoon, compiled to knock, that runs in the knock interpreter. You need a runtime to actually handle data, to write data to disk, to persist the data. So you need an event log and snapshotting system. And finally, you need some way to actually interact with the thing. And so that was a command line interface. These days, that's Dojo and Dill. There was a different system originally, but maybe it was unlikely for this to happen, but this all actually got done. And this was done roughly around 2010, something like that. So almost the first decade of working on the system was just getting it from nothing to something very basic. It's a long time, but it was done that way to get it right. And sure enough, knock is at version 4, and it's Kelvin version, meaning it goes down to 0. So there are only 4 more times that we can ever change knock, and it's not clear that we're ever going to change it again. It might be good enough as it is. So it's pretty good. So the next stage, after this very initial, sort of tiny system, was to have this computer actually start to do some things. So the first thing you need a modern computer to do is communicate with other computers. It's a sort of virtual first, or digital first world. So you need encrypted peer-to-peer networking. That's the Ames network protocol. And that was written pretty early on, and that's still what we use. And this is implemented in the kernel. You also need a web server. So that's called Air, named after Jane Eyre. And that's because it's important for Urbit to be able to communicate with the boomer web, right? You need a bridge between the old world and the new. You also need source control, right? So you need to be able to store source code, build source code, turn it into programs, run the programs. So that's Clay and Ford. And you need timers because time exists, keeps moving. Can't do anything about it. You need to know it. And finally, you need some way of running apps. Because this is the whole point of an operating system, is to provide an environment that you can actually run code in. So Gall was written to run applications. And so all this got done by roughly 2015, let's say. So another 5 years. And this forms the core, this forms the core still of Urbit today, at least within the kernel. Okay, so we went from nothing to an idea to a tiny little system that works to a system that can actually, is an operating system and can run some stuff. And then the next step was to actually decentralize the identity system. So Urbit, from the very beginning, had some idea of an identity, right? Like my Urbit identity is Robness Rickfer. That's actually a 32-bit number, right? And the idea of Urbit is that you are known by this 32-bit number, and you can pronounce it, and it can be used efficiently in code. It's your network address. You own it, the way you own crypto. Well, you do now. When it first got started, Talon stored all of the ownership information. I don't remember how it worked. I think it was like in Galen's email or something. Like maybe there was some advanced tech involving a spreadsheet. And that was okay for a while, but Urbit needs to belong to everyone. And so in 2017 or so, started working on making this a real decentralized identity system. Fortunately, by that time, blockchains had been invented. And so we didn't have to figure out how to solve the double spend problem ourselves. And so we decided to use Ethereum's solution to that. And that's how we ended up with Azimuth, which is the system that we use to this day. That was deployed in, I think, early 2019. And then also, not only did we need to have that part of the system sort of be live on a blockchain, but we also needed interfaces to it. So you need a user interface to it for people. That's a bridge. So that's a web interface where you can manage your keys and that sort of thing. And you also need an interface to it from the operating system itself. So that's the jail secret storage module. And we had to rewrite the Ames networking protocol to actually use this sort of more robust public key infrastructure. So we did all that. So that was done by about end of 2019. All right, there's just a couple more entries here. We're coming close to present day. Okay, so now we have a real computer, a real operating system, and you can actually own it in a, not your keys, not your ship kind of way. And okay, what do people want to do with this thing? It's like, well, they want to talk to each other. Primarily, Urbit is a network of social networks. And there are a lot of things that you might want to do with those social networks, but the first thing you need to do is be able to send chat messages and form groups. So Landscape, the web interface, which you heard Josh and Galen talked about earlier. Groups is a big part of that. And some other features of that stuff. So you want an ability to link to data, have groups that can send links across groups and across chats and whatnot. So that's Graph Store, facilitates that. And you also need a way of notifying the user when something happened. All right. Okay, so built all that. And this stuff actually works pretty decently these days. It took a couple of years to get there. It took a lot of work by a lot of people. But now we have a pretty workable social networking system on Urbit, and yeah, I think most of us in this room are on that every day. There's more posts coming through than I can keep up with. And it's really nice. I mean, that wasn't the case when I first joined. So that's been a big shift. Okay, so now, last couple of things we did in the past year or so were these two things. We got updates to work. So Urbit has an over-the-air update system, an OTA. You may hear people sort of, especially a year ago, you might hear people being scared that, uh-oh, an OTA is coming, your ship might not work for a while. It's actually much less scary today, and in fact, now we push out OTAs usually a couple times a week, sometimes multiple times a day. Usually most users don't notice. We pushed out a rough one a little while ago, sorry about that, but that was the one that enabled us to do software distribution, which is the demo that you just saw. So in order to get to software distribution, we actually had to have some way of being able to download code, take the code that's running, migrate it over to the new thing, and sync further updates from a remote upstream. That was always part of the design of the system, but until about a year ago, it just didn't really work. So now it works, and that's why the demo worked, part of it. Okay, so now we're at the present day. This is where we're at now. So now I'm going to discuss what's coming next, right? And this affects which kinds of apps you can build now and what kinds of apps you'll be able to build in the future. I don't know what's going on here. What are you doing? We lost the slides. All right, well, I'll just tell you while we're, fortunately, the audio is still going. Okay, so I had 4 things on the slide there, but only the last 2 are important, which are scaling and hardening. So these are the next 2 things we need to do with the system. And they're really whole sort of categories of tasks. Yeah, there we are. Okay, thank you. So event log and truncation, backups, these are important, but they're on their way to being done, so I'm just going to pretend like they already are done. And this is what I'm going to really talk about in this talk, is scaling and hardening. And they're whole sort of classes of activity. So basically, what I've told you so far is like Urbit went from nothing to this thing that you can use. People really care about it. And it doesn't need to be like industrial scale, industrially hardened, not to the level of something like Facebook that is responsible for storing everybody's data in one place. So we have an easier problem on our hands in a lot of ways, because it's a better problem to solve. Like most people aren't actually trying to communicate with the entire world at once. So it's a more natural sort of solution in general, which is part of why it's a good idea. But that being said, we do need to scale this thing up. The network is almost certainly going to be growing a lot over the next year or 2. And so we need the system to handle that, both in terms of sort of data throughput, data storage, networking, that kind of stuff, and then also in terms of having it being robust against various kinds of bad actors and attack. All right, so I'll talk about scaling first. There are basically 3 kinds of scaling: network, storage, and computation. So I'll talk about networking first. AIMS, Urbits network protocol, was recently benchmarked by Edouard Urcades, one of our network engineers, as having about the same speed as a 56K modem. So this fits with the theme of Urbit bringing personal computing into the 90s, but not really the way we were hoping for. So this isn't great. Fortunately, it works basically fine for what we're using it for at the moment, but Urbit should be able to max out a network connection, right? Like however fast your internet is, Urbit should go that fast. So that's something that we're going to have to fix, and something that's very much on our minds at Salon at the moment. And there's another kind of problem with networking. So let's assume that Kanye West gets on the network in a few months. And he puts out a post like this. God is so good. Today I'm voting for the first time in my life for the President of the United States, and it's for someone I truly trust, me. American flag, and I don't know if that's like a cactus or something next to it, whatever. The point is that people really like this post. 183,000 people like this post. And we don't want Kanye shouting into the void, right? If somebody posts something on Urbit, then it's important for that to actually be able to distribute widely and distribute efficiently, which means that the marginal cost of sending a post, sending a piece of data to one more ship on the network needs to be really low. So this is what we call scalable content distribution or scalable data dissemination. When we say those words, this is what we mean. So we have a bunch of ideas for how to do this. Most of them rely at least somewhat on making better use of Urbit's immutable scry namespace, which is one of the coolest features of Urbit that we really haven't explored that much. I am personally invested in a lot of designs regarding that, but in any case, this is a problem that we're going to have to solve somehow for a lot of different applications, because there's a lot of things where you need to be doing basically closer to global broadcasts or having a lot of subscribers follow your one ship. So this is important. This is one of the major things that we're going to be addressing at Talon over the next year or two. Second kind of scaling is scaling storage. So you may know that at the moment, Urbit can't store more than 2 gigabytes of data. It's an implementation detail. It's just part of how it works. It's not a fundamental limitation of the system, but it's a limitation. And so a lot of Urbits end up looking kind of like this after a while. The desk there is a bunch of graph store data. And so this isn't a great situation. It's important for me to be able to import my director's cut edition of Shrek 2 into my Urbit. It's probably bigger than 2 gigabytes. And just like being able to max out a network connection, your Urbit should be able to max out your hard drive. So that's something we also need to address. Instead, your Urbit should feel a little bit more like this. Personal, but spacious, comfortable. So we'll get there. And the third and final kind of scaling that we need to do is computation scaling, which basically means, well, it means a couple things. One is that, so you may have heard that Urbit is not the fastest thing in the world. This is true. And it probably won't ever be the fastest thing in the world as like a single-threaded system. That's fine. It doesn't need to be. But it does need to be a bit faster than it is, especially as we run more code on it, have people rely on it more heavily. So there are a few different things that we need to do to make it go faster. One of them, well, okay, so here's the general approach to this. And this is something that Philip wrote in the Urbit Precepts document, which I recommend you all read. It's pretty cool. So he said, be simple and uncompromising in defining what's correct, go crazy with optimizations. So knock is simple and uncompromising in what's correct. The interpretation of knock is where the optimizations should lie. So there are a lot of optimizations we should do, and we've barely scratched the surface of this. So if there are any C programmers in the room who want to do some leet stuff, there's plenty of work for you to do. And in fact, Joe Nasser Morzad, right there, has a little list of some things that would be pretty fun to start hacking on there. One of the cooler features of Urbit is a system called Jets, which allows an optimized piece of code to be run instead of the knock if you know exactly which knock you were going to run, and you could just do it faster. So this Jet system has existed from the beginning. We're in the process of overhauling the Jet system to be more efficient and cleaner. Then there are a couple other ways to make it go faster than single-threaded performance, improvements to the memory allocator, compiling down to machine code, maybe using a JIT. Haven't figured it all out yet, but we're starting to work on this. It's very exciting. So Urbit will get faster. We'll see how much, but we're on that road now. The next thing that Urbit needs to be able to do is handle multiple reads in parallel. So right now, your Urbit can only run one thread at a time, and it's a sequential list of writes, right? So like a database, it can basically only do one write at a time in a row. This is related to determinism. However, most of what you do with a computer is actually a read, not a write. And reads should be able to go in parallel. So this is a way that, maybe Kanye's laptop can actually use all of its cores in handling requests for his tweets. All right, so that's scaling. The second category of task that remains for the kernel and the runtime is hardening. This means hardening against attack. So I don't want this guy reading my chats. Galen earlier was saying that Urbit should be simple, durable, and yours. And if this guy's pretending to be me and reading all my chats, then it's not really mine anymore. So Urbit needs to be secure, and especially because we really want there to be applications on Urbit that rely on dealing with sensitive data, such as non-custodial crypto wallets, password managers, things like this. You don't want to store your keys in Urbit right now, not like major keys. And that shouldn't be the case forever. So we need to harden the system so that people can run applications like this and have them be reasonable and trusted. There are a couple pieces to this. So one is the runtime. And the way we've approached this problem so far is essentially by just trying to get the architecture right. And this is sort of how we approach everything. And one of the best parts of the architecture of the Urbit runtime is that the way it ingests data, any data, is one function. It's about 500 lines of code. You may know that in the past decade or so, many major languages and frameworks have had really serious security vulnerabilities in data deserialization. So fortunately for Urbit, all of our data deserialization happens with just one function. So it's like this castle having this one small drawbridge coming into it. There are other parts of the runtime that also need to be hardened. So memory allocator, jets, a couple other things. So that's not the full story, but that's the general approach. And so what we're going to have to do is we're going to have to poke at this thing and see if there are any soft spots and make sure that, while the design is solid, we'll have to make sure that the actual implementation is as well. The next thing that has to be hardened is the application kernel interface. This was sort of touched on briefly by Josh, and I'd like to clarify something. It is in fact still the case that if you install an app, it could reinstall your kernel. So don't be under any illusions about that. If you install an app, only install it from a trusted source. For now, we'll let you know once that's not the case. But what did change with software distribution is that won't happen accidentally. And when you download an app, you're not downloading a new kernel. It has to ask if it wants to reinstall the kernel. And so because it has to ask, what we need now is a way for the kernel to say no. So that's basically a permissioning system. That permissioning system is probably going to look a fair amount like the sort of iOS permissioning where your app says, hey, can I use the camera? And you get to say no, right? That sort of thing. It'll look a little different in Urbit because your Urbit is a server, so there's a sort of somewhat different set of permissions that you may want to grant or rescind to any application. But it's a similar idea, right? So the kernel needs to maintain control over data usage, right? Like how much data is being stored, how much data am I accepting from other people. It needs to maintain control over computation, make sure that there isn't one app that's sort of hogging the CPU. And also, you might want to be able to limit the network usage of any application. There are other forms of permissioning too. These are a few examples. So, to conclude, Urbit has made a lot of progress. It's made a lot of progress from being nothing in 2002, and So I joined Talon in just over 4 years ago in mid-2017. And at the time, Urbit took about 30 seconds to load a web page, if you were lucky and it didn't just time out and not work at all. And about a few times a week, it would just crash, run out of memory, something horrible would happen. That doesn't happen anymore. My Urbit has been running for over a year, pretty stably. I use it all the time. I use it on my phone. You know, that's a very different situation. And now it's at the point where I'm starting to run apps that my friends wrote. And that feels really good. And they're coming in rapidly. Like Chess was apparently written this morning and published this morning. I haven't used it yet. I don't know who wrote it. You know, I mean, this is cool. So with that, I'll turn it over to Galen and we'll talk more about the future.
Thanks, man. Hey, I'm back. I'm also hungry. You guys hungry? I'm gonna do my best to let us all go eat. Oof, 4 fingers. Do I have 4 fingers? Sorry. Other way. No? That way? All the way over? There we go. Oof. Computers are complicated, man. Okay. We're gonna talk about the future of Urbit, apparently. I wrote this talk title a long time ago. It is, in fact, what I'm going to talk about, but I would have come up with a more pithy title if I had thought about it, I think. Anyway, I'm going to start with a story and then try and make it very concrete. So 2 weeks ago? Anyway, a couple weeks ago, I was talking to one of our earliest investors and an advisor who I absolutely love, gets it, worked on one of the most dominant platforms that we all use. And in the spirit of this event, I'm not going to name this person, but the story is good. So I got on the phone with this guy, and he's like, "You're blowing it. Galaxy should be worth $100 million. What's going on?" It's like, I'm kidding. It's going pretty good, but, you know, you should always think like it could be going better. He's right. I was like, look, you know, I think it's going, you know, what I like is that the enthusiasm for what we do is moving forward like in lockstep with its maturity. Urbit's getting better, people understand it better. You know, we don't bullshit people at all. In fact, I certainly personally, if you know me personally, you know this, I'm like completely allergic to the hype cycle of technology. It drives me crazy. I don't like bullshitting people because I think the thesis is basically that tools are better than, you know, hype-filled bullshit. Like, I want to use something that represents itself as something, you know, other than what it actually is. So this guy agreed with me. He said, okay, fine, you're right. You want to validate that. You want to validate that, you know, Urbit should be exactly what it says it is. But one way that you can short circuit, you know, that as being your sort of primary way of communicating is to also to tell stories about the future. But just be honest. So paint a picture of where you're going and tell people exactly what it is. So I'll try and do that relatively quickly out of motivation from my desire to eat lunch. Anyway, so, and in service of that and getting us all to eat, there are a few things I'm not going to talk about, which we could talk about at length, and I encourage you to talk about at length. So I'm not going to talk about fleets of farming robots that run Urbit, or the Urbit Internet of Things, or Urbit as the best platform for ubiquitous computing, which I definitely think it is, and this is something you can spend hours talking about. I'm not going to talk about Urbit as a permanent archive that you can hand down to your grandchildren, even though Urbit is very much designed in that spirit, and I think can satisfy that vision. And I'm also not going to talk about global pseudonymous medical research, which I just had a 2-hour conversation about the other day with someone I had never met before, who's a medical student, who convinced me, I'd thought about this a little bit, who had was taking this idea seriously. And now I'm tempted to dive into this subject. It's very interesting, but I encourage you to dive into it, because it's actually kind of an obvious thing that Urbit could be good for. I'm going to talk about something pretty simple and concrete that I think is almost obvious at this point, that actually I've been kind of talking about for years. You've probably already heard me talk about it, which we can now call Digital Basics OS. This is an informal collaboration between me and Ed, because Ed's always talking about Digital Basics, and I just want to use a computer that feels good. we say OS in this really informal way. I think of OS, it drives some people crazy. Like Urbit obviously doesn't run on Metal. I mean OS like from a user experience standpoint, right? So, to frame it in a classic Silicon Valley pitch format, it's like Muji meets WeChat, but it's an operating system. I think this is great. I told this to someone the other day, and they were like, wait, what's Muji? Okay, fine. Actually, totally fair. Muji is a Japanese company that you maybe have never heard of. This is Muji in Ginza in Tokyo, which is a place that I miss and recommend you visit, not the Muji store, but Japan in general. And you can see, I think, just by looking at it, kind of what Muji is on about, right? Muji means no brand, and their whole thing is basically unbranded, high-quality goods. One of the most interesting things about Muji is that it was started during a time of sort of total decadence in Japan. So during the late 80s, early 90s, which you guys are all familiar with the vibe of late 80s, early 90s Japan, right? It's kind of similar to like how we think about China now, where they're like, their economy is booming. Everyone's like, Japan's going to take over the world. We're all going to work for Japan. These guys, they're going to make it. The fashion of that period is like extreme, like outward displays of wealth. And Muji was like, you know what? We're not feeling this. Let's make things that are just really, really nice and are not about displaying how much money you have and just are things that you want to use around the house that actually work and make sense. It's worth looking into as a project. I think it's extremely successful. They make really nice things. And of course, the whole aim of this is to just give you stuff that you can actually use, that you can, design your own environment with. IKEA is maybe built in like a similar spirit. They're kind of spiritually similar projects. WeChat, man, WeChat's hard to explain. Also because I feel weird using this example because I don't use WeChat, but I feel like I've done enough research to talk about it, but I should fully admit that like I'm not a day-to-day user of WeChat. And in trying to explain, I'm like, okay, how do I explain WeChat to people? Because everyone knows what it is, so maybe it's stupid to explain it, but I like this example. It's really simple, which is just like a user UI walkthrough. Okay, so at the highest level, WeChat, like KakaoTalk and Line, is one of these super apps in Asia where you kind of do everything in one place. So we live in this stupid world where we switch between things like Facebook, Instagram, Twitter, Google Docs, Asana, GitHub, Notion, Arena. You guys want to keep going? I don't know. How did this happen? In any event, there's one way you can work around this is by being, by basically figuring out how to basically build really super centralized services that you can almost compel people to use. But the effect of that from an interface standpoint is amazing. Because, okay, here's someone booking a doctor's appointment from within the same app that they make payments, talk to people, probably write, communicate with their families, interact with their children's schools. I'm trying to think of the other. There's so many examples out there. I mean, there are probably people who use WeChat from day to day in here. Talk to them. Look at this thing. It actually feels like an operating system. Like it has user interface standardization, and you can do all of this different stuff there. I mean, social networks, okay, fine. Social networks are kind of cool. Like, this is cool. Like, this is interesting. Like, how do we get here? So what I want to talk about is how you get there by way of trying to build basically a suite of simple, reliable digital tools that satisfy more or less what WeChat does, by keeping you connected to the communities and people you care about so that you can build and foster those communities and that you can engage in kind of person-sized commerce. So not for giant businesses, but for us to split a check, interact with a small business, whatever. So yeah, my argument is basically that that Urbit is uniquely suited to do this, and interestingly that I think we can do it together. And so you can effectively sort of pull off a WeChat without the centralization, without the surveillance by a giant government. And so you can build a kind of Western version of this as a totally open platform, like as an operating system. So first I want to talk about why Urbit can do this. And I actually honestly think that Urbit is the only thing that can do this. We can talk after about why it's worth doing. Maybe I talked about that earlier. And then I'll try and be concrete about sort of like where we can go and how we're kind of on the road there. So the first thing is let's talk about this technically, but quickly. Okay, we use a bunch of different apps, like Pac-Man on top of Pac-Man and 2 nested circles, whatever. Just imagine that you could literally pick any 2, pick any 6, okay? Every application has some tower of individual components that are held together with duct tape or glue or rope or something. And they have some, well, you can't see this. Anyway, this should say my identity. So you have some authentication, you store my data, and you let me compute. Each one is totally separate, right? And they all run on top of Unix and the internet. So these things are never going to talk to each other. They're never going to interoperate because it's like technically totally impossible and infeasible. Not only are they never incentivized to do so, these things will never work together. So the possibility of making these things feel like an operating system is just not going to happen. It's never going to happen. It's just impossible. On the other hand, you look at the Urbit model. This looks a little washed out, which is basically like a solid piece of stone. It's one thing, single system, that has my identity, my data, and my ability to compute. And then on top of that, the idea with Landscape is to build an environment inside of which applications run. So you have no problem for apps to share data, for them to even use the same interface toolkit, and for it to feel like a single environment. Yeah. Missed the beat for the arrow, but you get it. It's one system. So, worth pointing out, I don't like to talk too much shit, but you can't do this with a blockchain, okay? Blockchains are cool, but like, this is not what blockchains do. Like, you can't do this with decentralized storage either. I mean, also important, actually, Urbit cooperates with these systems really nicely, and there are things that these systems do that are important in terms of reaching consensus and making sure that things last a long time, like sort of Wikipedia-like things. But you still need a place to compute. You're always going to need a place to compute, something that actually hosts your interface. So the beginning of this, man, you guys have seen this image a lot. I'm sorry. Is this. I'm just going to keep repeating it, and you're going to keep seeing it. Anyway, look, you want to build something where you have a bunch of apps that interoperate and feels like a single system. Great, well, you kind of do. I mean, it's not exactly the most mature version of it, but you have the beginning of it. And so if you want to get to this point where I have these, I mean, what do you do using cloud services today? Forget about the brands. You send messages to people, you write, you collaborate in different ways. It's actually not really that complicated. So like, if you just go through all the things you do and you pull, tear the brands off them, just sort of like abstract away the specificity of all of these individual things, well, we're kind of on the road there. You can imagine this just getting bigger, right? Let me pay people, let me write in long form, let me connect to the sensors in a world around me, let me understand my environment somehow. This can expand quite a lot. And I look forward to doing it with everyone else. What's interesting about this is that we can do this not as some kind of singular thing that we just make up, design, and hand to you, but that's like an ongoing collaborative project by the people involved. Okay, we're not there yet. There are huge challenges to getting there. But I do think the simple framework for getting there is pretty much in place, which is actually like kind of a relief from my perspective. From your perspective, it should be exciting, but I've been wanting to do this for a long time. So there are definitely challenges, but I think the nice thing about these challenges is that you can definitely see them. So onboarding is one, working on it. You need people to be able to sign up and use something like this incredibly easily. That feels like probably the most important thing to me, but it's also the biggest priority for Tlon, just to make that incredibly easy. We need the developer experience to be a lot better. It's nice to bring together, we tried our best with this event to bring together people who are very motivated to work on this thing. And while you can build and ship apps on Urbit today, the developer experience is still, you will see, it's actually not bad, but it can be a lot better. And then you also really need an interface framework by which developers who build apps on this thing can share components and get that level of UI standardization that you really want out of a sort of like Western WeChat meets Muji Digital Basics OS experience. So one thing that's weird about these past, when did this really start? It's basically been 18 months. There was a time where I thought that we were going to have to go out and make the world believe that this vision of the future was worth going after. But somehow, things have changed where it seems more like people are coming to us saying, okay, is it ready yet? Like, can we just do this thing? Like, we're ready to do this. And it does feel like the world is moving in this direction where actually, yeah, like these two things are kind of on a path where they collide, which is exciting. My feeling is that the thread of personal computing sort of disappeared as we moved to the cloud. There was a time where you still had desktop computers that connected to one another, and it felt like this exciting and interesting thing. And it just sort of died. I think we have the opportunity to pick that thread up again, and the effects of doing so are going to be pretty incredible. So I'll end where I started, which is that I do think that any serious technical project, any earnest effort to build new technology does start with the people who are involved and how they connect with one another and how they coordinate. So what time is it, like noon? I mean, we got, like 2 days to basically just enjoy this kind of thing. So connect with the people who are here. Thanks for coming, but enjoy it. I'm excited by all the conversations I've had so far, and just sort of excited to see what we can all do together. Thanks. Okay, wait. And did I even put them in here? Hold on a second. I'm supposed to do some housekeeping, and now I can't remember any of it. You want to do it?
I just have my thing.
Oh, okay. All right, let's see. Here's the boring stuff, but I'm glad that people haven't all left. If you're doing the workshop, it's going to be here. So Neil will replace me. Or you want to just hand me the list? There we go. I thought I put it in the notes, and I forgot. Okay, yeah, we're going to break for lunch. I think it's about, an hour or something, at least? Yeah. Workshop's going to happen here. Oh, yeah, if you have address space to claim, planets and stars, you can do that at the registration table. This next point doesn't make any sense. Add your unconferenced speech sign up? Okay, what's that mean? You can come up and tell us about that. Yeah, you want to come and explain that? I don't understand any of that. I mean, I know that's... I just, put slides together, man.
Thanks, Galen. That's okay. Well, no, it's covered. We got it.
Thanks.
We're having an unconference track. I'm Mike Osborne, by the way, Taller Ravnet. We're going to have the unconference track in the back corner in the other room. If you look on this wall on the opposite side here, there's a schedule. It's got a bunch of open space in it. If you don't know what an unconference track is, it's participant-generated content. So if you have a speech you'd like to give, a presentation, a roundtable, just invite people to talk about a certain subject, go ahead and sign yourself up, and we'll be running it back there. It's come as you are. Let's talk about what you're interested in. Thanks.
Okay, last thing, can you keep this brief and then we can go eat? I want to give a big thank you to all the people that actually helped make this organization, this event come together. Marissa, right here, the one in white. Yeah, she made this whole thing come together. And there's been a bunch of other people that have been involved as well. Christina, Mariah, everyone wearing a staff shirt, Mike here, a whole AV crew, Austin, who provided the space. I think he's right there. Big thank you, Austin. All right, countless other people I'm forgetting, but if you see staff, thanks, everybody. Okay, let's eat.